record this and then I'll post it afterwards. Okay, so if you haven't had a chance to download the notes, you can follow along on your own sheet of paper or with just the review here. Okay, so let's get started. Transformations. Here's our summary. We had this summary at the end of chapter 1. We have two types of transformations, the vertical ones and the horizontal ones. So if we have a function y equals f of x, our translations vertically, we add k. Reflection in the x-axis, it's negative of the whole parent function, or whatever function you're given. A stretch or a shrink is a number multiplied to the function, okay? So vertical transformations are all applied to the f of x, to the function as a whole. Horizontal ones are all applied to the x term of the function. So translation left or right, the x is replaced with x minus h. Reflection in the y-axis, x is replaced with negative x. And a stretch or a shrink, remember it's by 1 over a, x is replaced by a over x. Okay, so here we go. I have a parent function that's not just y equals x squared, it's y equals x squared plus 2x. And I want to describe what transformations occurred to y to get g of x. I will tell you there's 2 of them. So, Eli, what do you think? You remember functions?
Wait, and the standard, wait, what's the standard parent function again?
Well, this
Y
is
equals
our
x
parent
squared?
function that we're working with right now. Y
Okay.
squared plus 2x. This function is being transformed by changing it in this way. Eli, do you feel like you can come up with the 2 transformations on that?
No, I want to see if someone else do it. No, I can do it.
Okay. Becca is volunteered.
Okay, I'm going to guess that at the very end it's -1. So I'm going to guess that it's being moved 1 down.
Good.
I've noticed that on both of the parentheses it says +3.
Uh-huh.
It's being moved left, but I'm not sure if it's being moved left twice or if you got to put it in both of them so that the
Just once. It's just moved once because the x, everywhere we have x, is replaced with.
Okay, so yeah.
You have to replace like both x's with x plus
1
3.
down and 3 left.
Very good. Nicely done. Well done. Okay, so this is a 1 down, 3 left. Okay. B has, no, it only has 1. It has 1 transfer.
Hey, I'm confused. How did you get 1 down? Like, oh,
Okay.
oh, I remember. Okay. Wait, but how did you get?
This
Okay,
is,
I remember now. I remember it was a long time ago. All
yeah,
right,
this is the 2x. So -1 was
Right.
after the x squared plus 2x. It's moved down 1. And the x has been replaced with x plus 3.
Okay, I remember now.
Hey, I'm glad you asked those questions. That's why we're doing this summary, so you get to do that. Okay, Josh, you want to give it a try for part B?
Sure. So it is a vertical or a horizontal shrink by a factor of 2.
Okay, it is a horizontal, but since it's a factor of 2, it actually stretches it. Okay, but you're
And wait, if it
right.
and it's a shrink when it's less than 1.
It's going to be a shrink when we have this would like if this was 2. If we have this one, let me give you another one. Okay, if we have this one, our x is replaced with 2x, so this one would be a horizontal shrink of 1/2.
A horizontal shrink of 1/2. Okay, because it's 1 over a. Yeah. Okay. I'm remembering being confused by this all over again.
Okay.
Can I do C?
What's that?
Can I do C?
Yes, you can. There's
Okay.
2 of them, I'll tell you that.
Yes. So it looks like it's a reflection in the x-axis.
Uh-huh.
And
Tell me why. Tell me why.
is the negative is outside the whole function, so that means it's vertical. So that means it's a reflection in the x-axis.
Uh-huh.
And And it's up 5 because it's
Okay.
+5 at the end.
Yeah. And you gave that in the right order, followed by a translation up 5. What would be different if I wrote it this way?
It'd be down 5, I guess.
Okay, it would be down 5, or we could say it this way. It's up 5 first, and then it's a reflection over in the x-axis, over the x-axis. Okay. So in this case, we would say that,
When would it be a reflection in the y-axis?
good question. Let me finish this one.
Alright.
So the translation up 5, followed by a reflection.
Wait, can you push your paper down a little bit?
Oops, yep.
Thank you.
And wait, and hang on. When it's the reflection in the x-axis first, basically followed by up 5, it kind of doesn't like it's
We did the
wait,
negative
hang on.
of x squared plus 2x plus 5, and after we did the negative of 2x squared plus 2x, we added 5 afterwards. So we did the negative of our parent function, which was the reflection in the x-axis, and after we did the negative of the parent function, we added 5. Okay, this one, we do the plus 5 first, and then we take the result and we do the negative. So this one did the up 5 first, and then the reflection.
Yeah, it gets really complicated with like which goes first when we have mixes of shrinks or stretches, and then
Mhm.
also
Okay, we can always tell because vertical follows the order of operations. Okay, PEMDAS. And horizontal is as if you were solving an equation, so it reverses the order of operations. Okay. So vertical follows PEMDAS, horizontal reverses PEMDAS. And we see that reversal because our situation here, when we did x plus 3, we reversed it, so we went left 3. Okay. Let me do D, and then I will come back to Eli's question about a reflection in the y-axis. Let's see. Daniel, we have one parenthesis missing here. There we go. Okay. Tell me what this one is. Actually, there's 2 here. No, I wrote this one wrong. I'm going to throw this one out. I see that I'm not sure what I wrote there. Let's
oh, wait,
do it.
what would that have been?
Yeah, it was kind of a mix. I don't know.
Wouldn't it be a horizontal stretch by 1/2 followed by a vertical stretch of 4?
Yeah, actually it would.
Or 1/3?
Josh, yes, let me rewrite this again. I have 3x squared plus 2 times 3x, and then I closed it. Okay, so Josh, go ahead and tell me what we have here.
We have a horizontal stretch by 1/3,
Okay.
followed by a vertical stretch by 4.
Mhm. And of course, since it's 1/3, it actually ends up being a shrink. And then a vertical stretch 4. Okay. And the reason we know it's a
Okay,
vertical.
Josh, can you explain through your reasoning?
Yes. So since we know that everything else is in the parentheses besides the 4, we know that the 4 went last.
Mhm.
And when we look, we see that the 3 it's 3 times x, which means it's horizontal. And if it's horizontal, then we know it has to be 1/3, which makes it a horizontal shrink. And then that all of that times 4. And since it's 4 times the whole thing instead of just x, we know it's a vertical stretch.
Okay. Well done, Josh. Does it make sense, Mikhail?
Yes.
Okay. All right. Let's do one last one here because we wanted to see what would happen with a horizontal reflection. So we might just replace the x with negative x. And so we would have something like this. Okay. So I've replaced x with negative x.
Oh, the negative is in the parentheses?
Yeah. Mm-hmm. And the y-axis. Okay, or across the y-axis. Okay. So we added a couple. Okay. Now I have a couple of graphs here, and I actually have included the graph of f of x equals x squared. That's our parent function. And a second graph, and we want to describe the transformations that were done to f of x equals x squared to get our new function here. Michael, let's see what you think on that.
Okay, well, I'm really bad at the order that things happened in, but okay, before I try to figure out the order, I'm just going to say the things that definitely happened.
Okay.
Okay, well, it was a reflection over the x-axis because it's upside down now.
Uh-huh.
It obviously went up by, hang on, that's just 2. It went up 2,
Uh-huh.
or like it seemed like it did, and then it went to the side just 1.
Okay.
Okay, now I want to try to figure out what order that happened in.
Okay, so let's see what happens if I do it in the order that you gave it to me. I'm just going to do it step by step, okay?
Uh-huh.
So reflection in the x-axis takes it and flips it upside down like that.
Oh, that would work.
All right. Okay. And then if I take it, these two are translations. We can always do the translations
At the
together.
same time, yeah.
So we can move it to the right one and up 2. And so we get it. So yes, you did list it in the right order.
Hooray.
Okay.
Okay, and then what would happen if they were switched, if it was up to like if you could just like draw this in pencil
Yep.
kind of a
Okay,
little
so
bit.
it's blue. Is blue work? Okay, so if I did
Yeah.
the up to right one first, I would have this graph. And then if I reflect that over the x-axis, I would be down here.
Okay, I see. Because you
Okay.
were raised above the x-axis beforehand, so you
Yeah.
would have. Okay,
Okay.
I get it.
Okay.
Okay.
So how would I rewrite this function? Could I write an equation for that? Volunteers to write an equation. Isaiah, I haven't heard from you today. Do you think you could write an equation for this new function with a reflection in the x-axis up 2 and right 1?
G of x equals negative x squared
Mhm.
parentheses minus 1.
Okay, my first step would take us there. I will agree with that. That's your reflection. And let's call it a next one then. What would I do to this to do the up 2 and the right 1?
Factor it.
Okay, I am going to have some parentheses because my x is going to be replaced with x minus 1. And then what?
So it's going to be x minus 1
Okay,
and x plus 2.
okay, just plus 2. I took my function and I replaced x with x minus 1, and I took that function and I added 2 at the end.
So yeah, this works if you like even algebraically do the transformations in the order they were given.
Mm-hmm.
Just because like, and algebraically, if you had done it the other way, where if you had done the minus 1 up 2, then you would have all of that in parentheses,
Mm-hmm.
and then you did the negative.
Yeah, and so you would have seen it would have gone down 2 instead of up 2.
Okay, I have to go now.
All right. Okay, so here's another one. This is again y equals x squared.
Can I do it?
Mm-hmm. Yes, Emma.
Yes. So all that happened is it moved left 1. So
But
It's-
there's one more
is
thing
it
that happened. I want you to take a look at.
oh, it looks like it vertical stretch.
Okay. All right. So we also have a vertical stretch of 2. Okay. This one's horizontal
Uh-huh.
and the other one's vertical. So since they're not doing the same thing, we can do them in either order.
Okay.
So
Oh, let's do
what was my
left
new
one.
equation? Okay. So what's my
We'll
new?
do left 1 first. So it's x plus 1 squared.
Uh-huh.
And then vertical stretch of 2. So 2 is to the whole thing. So it's just 2 outside the parentheses. And then rest of
Okay. So I'm going to put you in breakout rooms. We have a half an hour to do it. You're going to work on the exploration on page 205, section 4.7. We're doing these slightly out of order. I didn't want to do 4.6 because we would have had to have homework, but 4.7 we could do the exploration. So we're doing these two in a reverse order. So 1, 2, 3, 4, 5, 6, 2 groups. Here we go. And
A girls group again?
what's that? You want a girls group
Girls
again?
group? Yeah.
One more time. But I like to mix things up a little bit. This time I'm going to let you guys get away with another girls group. I'd say Josh.
Which page is this again?
205. Emma, Hannah, Nora, Becca. All right, next time I'll mix things up. Okay, go. Yeah.
Cathcart, can you enable screen?
There.
Yeah.
Okay, let me do that. I keep forgetting. I should set that up so that you guys can do it all the time. There we go. All right, you guys are set.
Thank you.
Yes. And Emma, I know why you like being in the girls group. You were too long with a class full of all boys.
Tell me about it.
Okay.